Hello and good day, Algebra. Back with you in PO50, reviewing factoring trinomial expressions in ax squared plus bx plus c form, something that we started before spring break. We've had 10 days off, so there's probably some rust to shake off. But essentially what we're looking for here are what two binomials multiply to give us the original trinomial. So if you remember back in PO45, when we did the foil, the crab claw, the box, this is essentially the opposite of that. You did need to do 3 of them. Are there any that you want to talk about? I mean, it's really, we've gone through the steps as a class in a previous video. Now it's just applying them. Any on this page or the second page that you want to talk about and go over today? Maybe one that you haven't done yet, since the rest of it is all homework for tomorrow. That would be the ideal. Sorry, what? Fourth one, second page. Okay. Let's see. The 10x squared plus 10? Yeah. So this is the one that I did want to talk about specifically. And what's different about this, well, I'll put it in quotations, trinomial from the others that you have to factor? It's not a trinomial, is it? It's a binomial, right? 10x squared plus 10 equals 0. If we think about the standard form for a trinomial, which is ax squared plus bx plus c, that's a standard form for the equation of a parabola. Which term are we missing in 10x squared plus 10? Elise? The b term, right? That middle term. Our x squared term is always the a term. We have that. Our constant is always the constant, our c term. We have that. We're missing that bx term. And so if I were to rewrite this as a trinomial, and this kind of goes back to CO42 when we added and subtracted these, what term would I put in there to represent how many x's I have? Josh? 0x. Okay? So as a trinomial, we could write this to be 10x squared plus 0x plus 10. Now, why does that matter? Well, when we run through our steps here, there is no greatest common factor. Nothing we can factor out of 10, 0, and 10. So we go straight to step 2, which is multiplying a and c together. And this is why it's important to understand when these are written out in standard form, what's your a term, what's your b term, what's your c term. Okay, the a is always the x squared coefficient, the c is always the constant. And so a times c is 10 times 10, which is 100. So step 3 now is where we're looking for two numbers that multiply to make 100. That's why we have step 2, because we want to know what these numbers need to multiply to be. And the reason why we put that 0x there is because that is what these same two numbers have to add or subtract to. Equals 0. Okay? So we look for the factors of 100 that add or subtract to be 0. What do you mean none? What about 10 and 10? Right. You cannot add or subtract 10 and 10 to get 0 unless one of them's negative and one of them's positive, right? But when that breaks down, is that a negative 10 and a positive 10 don't multiply to make a positive 100. They make a negative 100. Okay? So this one has kind of two things to it. First of all, that 0x term. And then second of all, this is one of those situations, it's a prime example of a prime trinomial. In that it doesn't have any factors other than itself and 1. It doesn't mean it's not a parabola. It doesn't mean it's not a true equation. It's just like if I asked you to factor 13, you'd say, well, it's prime. Its only factors are itself and 1. Same thing here. It's a prime trinomial. That's all. Nothing wrong with it. Okay? Another one. Let's go over one that actually can be factors. We can run through all the steps together. Brent.
Like the first page of like full bottom row first one.
All right. The one that starts out with 8x squared minus 2x plus 10.
Yep.
So this one, won't take us long. The greatest common factor of 8, 2, and 10 is a 2. So we're going to factor that out first. And what we're left with now is what goes inside of the parentheses. Okay? And when we say factor out a 2, what we're doing is we're dividing each term here by 2. So it kind of goes back to PO47 a little bit. 8x squared divided by 2 is 4x squared. Negative 2x divided by 2 is a negative 1x. And 10 divided by 2 is a positive 5. So now in steps 2 and 3, kind of that combo platter of multiplying and dividing here, we're looking for a times c, which is 4 times 5. That gives us 20. And so we're looking for two numbers that multiply to equal positive 20, and those same two numbers add to equal negative 1. So to do this, you're going to look at the factor pairs of 20. We've got 1 and 20, 2 and 10, 4 and 5. Which one of those three factor pairs, because those are the only options, right? Those are the only three factor pairs that we can use here. Which one can we use to get a negative 1? Josh? 4 and 5. How? Okay. Negative 5 plus 4 equals negative 1. And those same two numbers, negative 5 times 4 is a negative 20, not a positive 20. Well, wait a minute now. What if we make our 4 negative? So it's negative 5 times negative 4. Negative 5 plus, oh, that's negative 9. Right. So this would be another example of one that is prime. Okay. It's got to work for both conditions here. Just like we saw in PO49, we had prime ones there also. It's got to work for both conditions, and if it doesn't, it's prime. That would be your answer. All it means is that you can't factor it. That's it. Any others to go over? One that we can take to the finish line. Emily. The fourth one? On the first page? So that would be, let's see, 28x squared minus 16x minus 12? Yeah? Oh, okay. This one's good. We can take this one to the finish line. So GCF of 28, 16, and 12 is a 4. So what that means is we are factoring out a 4 from each term, essentially doing the reverse of the distributive property, right? Dividing everything by 4. And that's going to give us 28x squared divided by 4 is 7x squared. Negative 16 divided by 4 is a negative 4x. And negative 12 divided by 4 is a negative 3. Step 2. We're looking for the a times the c, which ax squared plus bx plus c. Our a is 7. Our c is negative 3. And we're going to multiply those together to get negative 21. And that negative 21 is important because now in step 3, this is where we figure out what the constants of our two binomials are going to be. So we're looking for two numbers that multiply to equal negative 21. That's where we use what we got in step 2 there. And those same two numbers add or subtract to equal our middle term, negative 4. Who's got an answer? Brady.
Negative 7 and 3.
Negative 7 and 3. Negative 7 times 3 is negative 21. Negative 7 plus 3 equals negative 4. Okay. Any questions on what we've done so far here? Steps 2 and 3 are really, more step 3, but those are straight out of PO49, where you're trying to find the combination of numbers that's going to work here. And it's the factors that multiply and those same numbers add or subtract to get that middle term. Step 4 is where we kind of put it all together here. And we're going to start, because we had a greatest common factor, that goes in front. And then we have our two binomials that follow. This is a step that oftentimes gets missed or messed up. What term does each set of parentheses get? What term do we put in both? Brent? 7x, right. And the reason why we do that, if they both start the same way, that means it doesn't matter which one gets the -7 and which one gets the 3. Because at the end, it's going to matter which ones gets each of those. It's going to matter what the constants are. But by starting each of them the same, we can put the -7 in either one and the +3 in either one. Because in step 5, here's where we kind of fix it. Because right now, if we use FOIL crab claw box, 7x times 7x is not 7x squared. It's not going to work out, okay, because we gave each of them the 7x. But in step 5 is where we kind of fix that by doing what? What's step 5? Lucas? Simplify one or both of the parentheses. And in this case, we can only simplify the first one by dividing both terms by 7. That's the greatest common factor there. So our expression now reads 4 times 7x divided by 7 is just x. -7 divided by 7 is a -1. And our second set of parentheses does not change. Now we see that if we FOIL crab claw box our binomials here, that x times 7x does give us 7x squared. Okay, so we have to do step 5 because in step 4 we gave them both a 7x. And the reason for that was to make sure it didn't matter where our constants went. Right? Step 6. We take that greatest common factor, we distribute it back into our first set of parentheses only, and that gives us our final answer of 4x minus 4 and 7x plus 3. And if you FOIL, crab claw, or box that, you'll come back to the original trinomial of 28x squared minus 16x minus 12. Okay? So, you did a few of them before break. We've gone through a couple of them now. This one to completion. Is there any step that is giving you trouble? To where like, okay, I get that, but I get to this point and I get stuck. No? Okay, maybe you're not sure yet. That's right too. Is there another one that you'd like to go over? Bridget.
The last one, or the second to last one on the second page.
Okay. The 15x squared plus 14 one?
Yeah.
Okay. So this one, what's wrong with it? There's nothing wrong with it, but what do we have to do first here? What's the extra step? Yeah. Right. Like we talked about in PO49, in order to be factors, these equations have to equal 0. And so right now, 15x squared plus 14 equals -47x. We've got to move this term over to the other side using opposite operations and making sure we put it in the right spots. It's our bx term, so that we get 15x squared plus 47x plus 14 equals 0. Okay. Now we're in business. Is there a greatest common factor between 15, 47, and 14? No. So since we can't do step 1, it's going to be kind of annoying because our numbers are going to be bigger that we have to work with here, but it's kind of nice in that we get to skip step 1 and we also get to skip step 6 when we distribute the greatest common factor back in because there is no greatest common factor. Okay. So step 2, we're multiplying A and C together. Our A term is 15. Our C term is 14. And someone with a big brain, what's 15 times 14?
210.
Do we have a second on that?
Nope.
Okay. Oh, because we don't need one, right? Okay. 210. So we're looking for factors of 210, and those same numbers add or subtract to equal 47. Now, 210 is not really a number that you work with often, so it might just be kind of listing all the factor pairs, seeing what works. You might get lucky. Olivia? 42 and 5. 42 times 5 is 210. 42 plus 5 is 47. Okay. Now on step 4, because that was kind of step 2 and 3 together. Step 4, putting it all together. There is no greatest common factor, so we can just go straight to our parentheses here. What do both of them get? Noah? The 15x. And again, we do that just so it doesn't matter which one gets the 40 and which one gets the 5. Okay. This way we don't have to decide, well, how am I going to get 15x squared? Does one get a 3x and one get a 5x? Does one get an x and one get a 15x? By giving them both a 15x and then simplifying later, we eliminate all those different options. Okay. Then one of them gets a 42. The other one gets a 5. And we simplify. Step 5. What can we divide 15 and 42 by? Divide each by 3. So that gives us 5x plus 14. And what can we divide 15 and 5 by? I heard someone say 5, I think. So divide each of them by 5. And we get 3x plus 1. And the ones that you've done already, including this one here, what do you notice about what we divided by? What we simplified by in step 5? Anything stand out to you? And you look back at other ones that you've done also. This occurs more, it occurs often enough to say it's more than just a coincidence. The A term in this one, 15, we were able to simplify by 3 and 5, which, Elise, multiply to make 15. Right? That is, if you look back at other ones that you've done where you were able to simplify something, you'll notice on many of them that this happens. Okay, more than just a coincidence. But anyway, now that we are in step 6, we have no GCF to distribute. So our final step is just to check it. We multiply our coefficients, our x terms, 5x and 3x, give us 15x squared. That checks out. 14 times 1 is 14. There's our constant. And our inside-outside, 42 and 5, give us 47. So it works. Okay? Questions, comments, concerns, complaints, comments, congratulations, or criticisms? No? Very well. We can go over more after we stop recording, but they'll end it for this one. This is all due tomorrow, all of PO50 homework for tomorrow. That's how you math.